So we're actually going to do the do now together. I want us to find the area of the equilateral triangle with side lengths 8. So if you notice, what I've already done is I've labeled the side lengths as 8, but I've also dropped down in altitude. Now, in order to do this problem, there's a couple things we can do. We know the area of a triangle is half the base times the height. And if it's equilateral and one side is 8, all the sides are 8. So we obviously know the base is 8. We need to find the height. That's why I had dropped down the altitude for you. When we drop down this altitude, that base of 8 gets split into 2 4s because it creates 2 triangles that are congruent by dropping down that altitude. Now, the height is always made by a right angle. The height is always made by a right angle. So in order to find the area, I need to find the height. We can do the Pythagorean theorem. You could do 4 squared plus x squared equals 8 squared. That's absolutely okay. Or you can remember that if a triangle is equilateral, what else is it also? Triangle's equilateral, it's also, Demetri? Equiangular. So that means 180 divided by 3 is 60 degrees for each angle. And if each angle is 60 degrees, up top, that 60 degrees would have got split into a 30 and a 30. So now we have a 30, 60, 90 triangle. So I'm just going to use one of them because our goal right now is to find the length of the height. I'm going to redraw this 30, 60, 90 triangle so we don't get confused by anything else. We know the hypotenuse is 8, we know the lower base is 4, and we're trying to find the height. So we need to remember opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x. So we could either say 2x equals 8 and get x is 4, or you can say x right away equals 4. Doesn't matter. Either way, we end up getting x is equal to 4. So what is the height of this triangle? If x is equal to 4, the height is 4 root 3. Now we know the height. If we know the height and we know the base, we can now find the area. So go back to your formula. Area of a triangle is half the base times the height. Now, a few people on the quiz were saying the base is 4. Is the base 4? No, the base is the full base. The base is not full, the 4. The full base is 8. So we're half 8, and the height is 4 root 3. So I'm going to take half of 8 is 4, and then we're 4 times 4 root 3 is 16 root 3 units squared. That is the area of the triangle. So now what we're going to do is we're going to derive a formula. Instead of doing all this every time, instead of doing a 30, dropping down in altitude, and doing a 30, 60, 90, finding the height, then plugging in for half base times height, we're going to derive a formula for area of a triangle. So here is our equilateral triangle, and now I said the side length is S. So if one side length is S and it's equilateral, do we agree that all the side lengths are S? Now, when we drop down that altitude, since the base is S, but the altitude splits it in half, wouldn't it be S divided by 2 and then another S divided by 2? If at any point I lose you, let me know. Okay. So now, area of the triangle is half the base times the height. We need to find the height. So we're going to use the 30, 60, 90 triangle. Opposite the 30 is x. Do a different color here. Opposite the 30 is x. Opposite the 60 is x root 3. And opposite the 90 is 2x. We end up getting x is equal to s divided by 2. Everybody agree with that? X is equal to s divided by 2. So then the height of this is going to be s divided by 2, root 3. We still good? All right, so now let's find the area of this triangle. The area of this triangle is half. Now my base is not s divided by 2. What's my base? Full s, right? The full base is s. And the height is going to be s divided by 2, root 3. And now I'm just going to multiply. So now I'm going to say area of an equilateral triangle. We ready for this? I'm going to multiply all my numerators. 1 times s is s. What's s times s root 3? S times s is not 2s. S times s is s squared root 3. Then we multiply all the denominators. 2 times 1 is 2 times another 2 is 4. So to find the area of an equilateral triangle right away, without dropping in altitude, without making a 30, 60, 90 triangle, is s squared root 3 over 4. What do you think that s stands for? What do you think that s stands for, Kelly? The side length, exactly. That s stands for the side length. So let's go here. Area of an equilateral triangle that we should memorize is side squared root 3 over 4, where s is equal to a side length. So we're adding this to the list of formulas to memorize for Friday's test. Hopefully you didn't forget all the stuff you had to memorize for last Friday or last Thursday's. I don't remember when you took it. I think it was Friday quiz. Okay, so now we're going to talk about the area of a regular polygon. This is where things get a little bit complicated. So if you tend to not pay attention, today is the day you do not want to do that. You want to pay attention today because it is a little bit involved. It's not just like a one single formula and it's that simple. There's manipulation that we have to do. So before I can give you any formulas, there's some definitions we need to go through. So in a regular polygon, all sides are congruent and all interior angles are congruent. So in order for a figure to be considered regular, in order for a figure to be considered regular, it has to be equilateral as well as equiangular. So all the sides have to be congruent, all the interior angles have to be congruent. Is a rhombus a regular figure? Is a rhombus a regular figure? Yes or no? Is a rhombus a regular figure? Why or why not? All right, let's take a vote. How many people say yes, a rhombus is a regular figure? How many people say no? How many people don't know? Okay. I'm going with no, a rhombus is not regular. So in a rhombus, all sides are congruent. Do we all agree? But are all interior angles congruent? No, so it's not considered regular. So just because a polygon is equilateral does not mean it's equiangular. So therefore, a regular polygon, an equilateral polygon is not necessarily always a regular polygon. But then we think about a square. Is a square a regular polygon? How many people say yes, a square is a regular polygon? How many people say no? Good, a square is a regular polygon. Why? Because all the sides are congruent and all the interior angles are 90 degrees. All right, so some more definitions. Let's just write these down and then I'll explain to you. So in a regular polygon, O is the center of the polygon. OA is a radius. And OM is an apothem. Now, I say apothem. Some people say apothem. It doesn't matter. Potato, potato. All right, so where are these words coming from? Where have we seen center and radius before? With only what shape have we ever before this day heard center and radius? Nora? Circles. So why am I bringing them into regular polygons? Because anytime we have a regular polygon, what you're envisioning is that there is a circle circumscribed about this polygon. And if there's a circle circumscribed about the polygon, meaning the polygon vertices are all on the rim of the circle, all right, O would be the center of the circle, it's the center of the polygon. Wouldn't OA be a radius? So OA is the radius of the polygon. So this is where these words come into play, because it's always considering, when you have a regular polygon, you're considering a circle circumscribed about it, and that's where we get those words. So whether that circle's drawn or not, we sort of know it's there. All right, so we've got a new word here that we've never heard before. We never heard it in circles, we never heard it in triangles, we've never heard it, period. The apothem. So an apothem, oh, sorry, before we get to that, we got to talk about radius. A radius of a regular polygon is a segment joining the center to any vertex. And that's sort of what I was telling you here, because we're envisioning that a circle is circumscribed about this polygon. That's where that radius comes from. All right, some important observations about radii of regular polygons. A radius of a regular polygon is the radius of a circle circumscribed about the polygon. A radius of a regular polygon bisects an angle it intersects. If all the radii of a regular polygon are drawn, the polygon is divided into, let's draw in all our radii. Drawn in all our radii. What do we know about all radii? They're congruent. All radii are congruent. So all these segments are congruent. I've now taken this polygon and I've split it into what shape? By drawing in this radii. What have I created? What shape is this? Triangles. How many triangles? Yeah, so we've split them into triangles. And what do we know about all these triangles? What's their relationship to each other? Because of all the radii being congruent, and it's equilateral. So that means all these base sides are congruent. So what's the relationship between all these triangles? They are congruent. So if all the radii of a regular polygon are drawn, the polygon is divided into congruent isosceles triangles. All right, so now for our new word, an apothem of a regular polygon is a segment joining the center to the midpoint of any side. All right, special observations about apothems. So only regular polygons have apothems. All right, now here's something new. An apothem is a radius of a circle inscribed in a polygon. Write it down and then I'll show you. Okay, so what does that mean when I say it's a radius of a circle inscribed in a polygon? So if I'm drawing a circle inscribed in this polygon, all right, my circle's not the best, but there we are. Oops, I messed something up. That's one side I messed up. Try this again. Do it in pink so it stands out a little bit more. Okay, might might look a little bit more like an ellipse when I draw it than a circle, but it's supposed to be a circle. Okay, so here's our circle inscribed in our polygon. So look at this. Let's call this OM. All right, so OM is the apothem. What does the apothem do? It comes from the center. It goes to one of the sides of the polygon. It splits that polygon into two congruent segments. Now, in reference to the circle, do we agree that OM is a radius of that inside circle, the interior circle? And do we agree that this segment, let's call this, I don't know, OP. Oh, can't do it, O, QP. Do we agree this segment, QP, is tangent to the circle? What happens when a radius touches a tangent? Who remembers? What happens when a radius, Joe? It makes right angles. So not only is the apothem the bisector, it is the perpendicular bisector of that segment that it intersects. So apothems have a lot of power here. An apothem is the perpendicular bisector of the segment it intersects. Or I should say not segment, of the side it intersects. And since an apothem is a radius of a circle inscribed in the polygon, what do we know about all radii? All radii are congruent. Thank you. All radii are congruent, therefore all apothems are congruent. All right, so once upon a time, I used to make you derive the area, the formula for the area of a regular polygon by yourself, but I'm just going to give it to you today. So the area of a regular polygon is going to be the apothem times the perimeter. Where A is apothem and P is the perimeter. All right, are we ready to do some sample problems here? All right. A regular polygon has a perimeter of 40 and an apothem of 5. Find the polygon's area. Hold on, is it half the apothem times the perimeter? Is it apothem times perimeter? I feel like it's half the apothem times the perimeter, half the base. Yeah, I believe it's half the apothem times the perimeter. Hold on, let me just make sure of this. Hold on 1 second. Because apothem times perimeter doesn't make sense. I think we need half. Okay, that makes sense. You're such Yep, I'm right. Half the apothem times the perimeter. All right, good catch. Let's make sure we highlight this because apothem times perimeter wasn't making sense to me. So it's half the apothem times the perimeter. Okay, a regular polygon has a perimeter of 40 and an apothem of 5. Find the polygon's area. All right, keyword here. I see regular polygon and I see area. The minute I see regular polygon and I see area, I'm going to write down the area of a regular polygon formula. So area equals half the apothem times the perimeter. Well, this is very straightforward because I gave you the apothem and I gave you the perimeter. So the area is going to be half. My apothem is 5. My perimeter is 40. Remember, because multiplication is commutative, I don't have to take half of 5. I can take half of 40, which is 20. So then our area is going to be 5 times 20, which is 100 units squared. Now for number 2, it says an equilateral triangle has a side 10 centimeters long. Find the triangle's area. All right, so you can do it the old way. You can say, okay, here's my triangle. It has a side length 10, and because it's equilateral, all my side lengths are 10. And then you could go through and say, okay, well, area is equal to half the base times the height. And I have my base is 10. Do I have a height? No. So let me go ahead and drop down this altitude and split that base into 5 and 5. And continue to remember that if a triangle is equilateral, it's also equiangular, which means every angle is 60 degrees and the top angle is 30 degrees. So we know opposite the 30 is x, opposite the 60 is x root 3. So our height ends up being 5 root 3. So the area of this triangle is half. My base is not 5, my base is 10, and my height is 5 root 3. You go and take half of 10, and then we get 5. 5 times 5 root 3 is 25 root 3 centimeters squared. Absolutely perfectly fine. But what did we just derive in the beginning of class? Didn't we derive a formula for the area of an equilateral triangle? So if we wanted to make our lives a little bit easier, we can say the area of an equilateral triangle is equal to side squared root 3 over 4. Well, what is our side length? Isn't our side length 10 centimeters long? So now it's going to be 10 squared root 3 over 4. All right, according to order of operations, do we have to do exponents first or could we divide first? PEMDAS, exponents or divide? Exponents. So can I divide 10 and 4 or do I have to do 10 squared first? We have to do 10 squared first. So then this ends up becoming 100 root 3 over 4. And now we can divide. 100 root 3 divided by 4 is 25 root 3 centimeters squared. Did we get the same answer both ways? We sure did. Do I care what you do? No. Kaylee, you okay? Did I confuse you? Okay. Okay, so this is what I was saying when I said this section gets a little bit more complicated. It's not as straightforward. So it says a circle with a radius of 6 is inscribed in an equilateral triangle. Find the area of the triangle. So I'm going to sort of draw what's going on here. It says a circle with a radius of 6 is inscribed in the triangle. So I'm going to first draw my triangle. Now they're saying the circle's inscribed in the triangle. So does that mean the circle's going on the outside of the triangle or the inside of the triangle? Inscribed in. Inside. So here is my circle inside the triangle, and there's my center of the triangle and the circle. They're saying the circle has a radius of 6. Now, there are so many places we could draw the radius. I could draw the radius here, right? That's a radius of the circle. But if I draw the radius there, it's not going to help me. Who thinks they know where I can draw the radius so it could potentially help me, even if you don't really know what to do with it, but it just makes the most sense? Nora. Exactly, to one of the sides. So I'm going to draw this straight down. And why, and I know this is 6. All right, so why is this helpful? Well, this is a radius, and isn't the side of this triangle tangent to the circle? What happens when a radius touches a tangent? It is perpendicular. And what do we know? This is the perpendicular bisector, because now this is also the apothem. The apothem is the radius of a circle inscribed in a regular polygon. So then it bisects it as well. So now it says, find the area of this equilateral triangle. Because it's an equilateral triangle, we know the area of an equilateral triangle is side squared root 3 over 4. So all I really need to do is find a side length. All right, so what am I going to do? I'm going to draw all of those. Now what you need to do is we need to find, do we believe that these are all central angles that I just created? I created all central angles because they're at the center and they're made up of radii. All right, we've sort of done this before. I don't remember exactly one section, but I know we did that before when we had to find the degree of these central angles. And we had said, well, if the chords are congruent, then the arcs are congruent, then the central angles are congruent. So what I'm going to do is I'm going to say one central angle is equal to 360 divided by the number of sides. So here, one central angle is going to be 360 divided by 3. So one central angle will be 120 degrees. I'll let you all write that all down and then we'll keep going. Okay. So, what does this mean for us? This means, oops, let's go here. This is 120, this is 120. Can I zoom in anymore? Oh no, am I frozen? Okay, what do you think happens to this 120 that got split by the altitude or the apothem? It gets split into 60 and 60, which means what? We have a 30, 60, 90 triangle. So I'm going to redraw this 30, 60, 90 triangle. 30, 60. Try this again. So opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x. So here we're going to have x is equal to 6. So if x is equal to 6, then x root 3 is 6 root 3, and 2x is 12. Well, we only care about one side length. Is one side length 6 root 3? No. The full side length is 12 root 3. Are we okay? Everybody okay with how I got one side length to be 12 root 3? So now we're going to plug this into our formula, and this is where our algebra skills come in. I'm going to bring it all the way over here. Remember, area of an equilateral triangle is side squared root 3 over 4. All right, our side length is not 12. Our side length is 12 root 3, and we're going to have to square that. Times root 3 all over 4. So when I go into 12 root 3 squared, this is going to be 12 root 3 times another 12 root 3. Well, 12 times 12 is 144. Root 3 times root 3, who can tell me? Root 3 times root 3 is whole number 3. No more radical, whole number 3. And then we're still times root 3 all over 4. How many people at this point would multiply 144 and 3? I'll do what majority would do. Okay, that looks like majority. How many people would divide 4 and 144? You do that? Okay. Yeah, that probably would have been a little easier, but that's okay. Let's do 144 times 3. So 3 times 4 is 12. Carry that 1. 3 times 4 is 12. Plus 1 is 13. Carry the 1. So now we're at 432. So now we're 432 root 3 over 4. So now we have to take 432 and divide it by 4. 4 goes into 4 one time. Subtract, bring down the 3. 4 doesn't go into 3. So for me to bring down another number, what do I have to do? Put in a 0. You got it. Just reminding you of some elementary division. So now we bring down the 2. 4 goes into 32 8 times. So we get 108 root 3 as our area. There will definitely be a bunch of these on your test. All right, let's go on to the next one, which is similar to the first one, the one we just did. But you know what? I'm going to be honest with you. I'm giving you too much information here. So let's add a page to the end of your Cami, and let me tell you what I would give you on a test so we can at least prepare you properly, because I did too much for you in this problem. So we're going to say find the area of a regular hexagon with sides 18 units long. So find the area of a regular hexagon with side lengths 18 units long. Let you write it down. Before we do anything, I'm going to draw a hexagon. Okay, so I'm labeling out our steps here. Step number 1, label our side lengths. So 18, 18, 18, 18, 18. And then this bottom one, I'm going to draw it like this, 18. All right, step number 2. Draw radii. What do I mean when I say draw radii? We're drawing from the centers to where? When I say draw radii, from the centers to where? Nobody? All right, so when I say draw radii, it's from the center to the corners. Is this a center to a corner? No, that is not a center to the corner. Is this a center to a corner? Yes, that's what I want you to do. So I want you to draw the radii from the center to the corners. All right. I'll let you draw that. Then we're going to find one central angle. How do we find one central angle? 360 divided by the number of sides. So in this scenario, what are we going to do? 360 divided by 6. So what is each central angle? 60 degrees. I'm going to leave one of those triangles and not write the 60 in. If I'm going too fast, tell me to slow down. Anybody not understand any part of what I've done so far? Okay, next step. Draw your apothem in one triangle. All right, so I'm going to go, and I'm going to go in one triangle, and I'm going to now draw my apothem. And now when I draw that apothem, that 18 gets split into what and what? That 18 gets split into 9 and 9. And what about that 60-degree angle on top? What does that get split into? 30 and 30. So once again, what are we dealing with? 30, 60, 90. All right, step number 5. Find the apothem using the special triangle. So you all tell me, what is the length of this apothem? Jeff? You got it. This apothem is 9 root 3. All right, are we ready for our last step? Step number 6. Use formula. Area equals half the apothem times the perimeter to find the area. Okay, so now let's do this. So area equals half the apothem times the perimeter. We said our apothem is 9 root 3. What's our perimeter? Jeff? You got it. So we did 18 times 6. So we have 9 root 3 times 108. I'm going to take half of 108 is 54. Did anybody multiply 9 root 3 times 54? Tell me what you got. All right, so it's 486 root 3 units squared. Everybody have every part of this? Should you expect questions like this on your test? 100% absolutely. All right, let's go back. We don't need to worry about something like this. This was a challenge problem. We could just skip that. But I do want you to do independent number 6 so you could practice what we just did. So the radius, oh, this is a little bit different. Okay, I'll do independent number 6 with you. All right, so it says the radius of a regular hexagon is 12. Find the length of one side, find the apothem, find the area. All right, so first thing I'm going to do is draw a hexagon. And when they say the radius of a regular hexagon is 12, what is the radius? From the center to where? From the center to the corners. The radius is from the center to the corners. So I'm drawing in all the radii from the center to the corners. So we are 6, 6, 6, 6, 6, 6. Oh, no, not 6. Sorry. I read it. It was 12. Go back. 12, 12, 12, 12, 12, 12. There we go. So part 1, they're saying find the length of one side. What do you think I'm going to do? Very similar to the other problem we did. I'm just giving you different information. Wasn't somewhere in the middle here we had to create special kinds of triangles? So in order to create those special kinds of triangles, we need the central angles. How do I find the central angle? What am I going to do to find a central angle? You got it. We're going to do 360 divided by the number of sides, so we are at 60 degrees for each of these. I left one without writing the 60 degrees. Now we're going to pick one triangle and we are going to draw the apothem. And when I draw that apothem, it is the perpendicular bisector, but what happens to that top 60-degree angle? It gets split into 30 and then another 30. So we are 30, 60, 90. So we can take one of our special right triangles, one of our 30, 60, 90s. If you want to redraw it, you can redraw it. We know the hypotenuse is 12, so opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x. Do we agree that x is equal to 6? So if this is 6, then this is 6. And what's the apothem? 6 root 3. So it says find the length of one side. One side is not 6. What's one side? 12. Find the apothem. What did we say the apothem was? 6 root 3. Now find the area. What formula am I going to use to find the area? It's a regular polygon. Kaylee? You got it. So then our apothem is 6 root 3. Our perimeter is going to be 12 times 6. So we are half 6 root 3. I'm going to do 6 times 6. So we are half 6 root 3 times 36. So our area is going to be 216 root 3 units squared. Oops, that's not half, sorry. I already took the half there. I had done half of 12. That's where I got that 6 from. Alrighty, we are done for today. Your homework is here. It's in the textbook. Do it, practice this, because this might have been one of the harder lessons of the chapter.